so let's start with today's class. Okay. So we will try to keep this class a bit interactive. I'll start by introducing myself, and then we will move on to learning what is SQL and what are different databases that we use. So hi, my name is Atul, and I'm currently working as a senior data scientist at Publicis Sapient. I'm a graduate from IIT Kharagpur, and after completing my college, I joined Yes Bank as a data science manager, and currently I'm working as a senior data scientist at Publicis Sapient. So I've been in the industry for like about, including my internship from my college days, it's been around 2 to 3 years that I have been in a data science industry. And I this I can say that I have seen quite a bit of challenging cases where whatever you are learning right now will help you to solve those. Okay. So, okay, one more question. Like, how many of you are like, is there anybody or how many people are there who are currently uh, having any work experience in or around the Python on and SQL? Is there anybody who has done SQL previously, or has he been using structured query language over a period? Is anybody there in today's lecture? You can reply to me in the chat. Okay, so I guess we have few. Okay, there are people who have been practicing SQL for quite some time. Okay, so if so, I guess we have a mix of batch today, and so if people who don't know SQL, I hope this lecture will be very informative for you guys, and people who have done SQL previously in their college or in their job, you guys, like, it will be more of a revision class for you all. Okay, so I guess we are all good to go. So let's start today's lecture. Okay, so we have, okay, are more people joining or currently? Or I can, we are good to go, right? Okay, cool. Okay. So before starting SQL, let's just deep dive into what are databases and why do we use a database? So guys, since you have told me that you have been learning Python from, you have learned Python and pandas and data visualization in last few weeks. So what kind of data were you dealing with? And what was the size of the data in pandas, if I may ask? Like, were you dealing with CSVs? And if it was a CSV file, what is the size of the data that you came across? By size of the data means, I mean the number of rows and number of columns in the data set that you have been practicing. Please reply to me in the chat so that I can see. Yeah. Okay. So someone is saying that they had around thousands of rows, and 3,000 of rows. Okay. Okay. So I guess 3 to 5K rows and 300 columns. So just a reality check. This type of data set is this is a very small database, and you are never going to find this small database whenever you are working on any project, a real-time project. So as of now, it was just for your practice. So I think you have been working on small databases, but as you progressed in your career as a data scientist, you will never be seeing the data that is this small. Usually the data sets that are used in companies are more or less billion to billions of rows and thousands of columns big. So the things that you have learned right now in pandas on data visualization and data processing, it will not be very helpful when you are dealing with data of in size of millions and billions, because pandas and Excel sheets tend to be quite slow in handling a database this large. So for that, we use database management systems, and we are going to study about those in today's lecture. Okay. So today's lecture will comprise of introduction to databases, what are relational and non-relational databases, and few examples of each. We will also see which database to choose from when we are given a problem statement. Then we will move forward with SQL, and we will try to understand what SQL is and what are the basic syntax queries that we use to fetch data from a SQL server. Before that, we will also try to understand and try to see that what are the different tools that we can use uh, in order to write queries and fetch and do some data exploration in SQL. And we will end in today's lecture by going through few of the basic SQL statements. So let's start today's lecture by a brief introduction to types of databases. Okay. So we have generally two types of databases. As a data scientist, you will encounter mainly two types of databases that are relational and non-relational database. Okay. So let's take example. Suppose that you are a person, and suppose that you have data a data set in front of you, and you have two options: either to place that data set in an Excel sheet or a Word document. So what will you guys do? Right now, I have not given you any in-depth information about the data. So uh, just a bit over, just a bit. What can I say? Just for a bit of intuition, where will you like to place your data? Do you want to place your data in Excel sheet or a Word document? Okay. So majority of people, like everybody has written, they want to place their data in Excel sheet, which is, yes, this is a fairly straightforward thing to say, because I haven't given you the information what type of data do you have. Okay, so it can be pre-assumed that data must be having features, which will be the columns, and the data, which will be the rows. So it can easily fit into a table or an Excel sheet. But what if the data is an image? What if the data is having too many images? Like data is a set of images. So in that case, you won't be using Excel, right? You need some other sort of database management system in order to store those images. Or what if you have a text file that is having sentences in it? Yeah. So if you have a text file that has sentences in it, again, you cannot store it in an Excel file. You need to use a Word document. So let's deep dive into what kind of databases to use, and what are these databases when that we encounter. So the first one is relational database. So suppose that you prefer to store your data in an Excel sheet because it fits nicely into rows and columns. So a relational database is the one that stores data in form of tables. The relationship that each point between data points is clear, and searching through those relationships is quite easy. For example, let's have a look at these three tables right now. Okay, so as you can see, if I want to find so the first table is, say, the name of a dog, the Fido, Rex, Bubbles, or Cujo. What type of food preferences does a dog have, and is the dog a like a well-behaved dog or not a well-behaved dog? Okay, suppose is second table, we have different tags associated with each of the dogs: height in inches of each of the dog, and the weight in lbs. Okay, and in the third table, we have breed of the dog, what color is the dog in, and what is the age of the dog. So can you see that if I want to find out the height of say height of a dog whose weight is above 100 pounds, so you can easily find it from these tables, right? Because these three tables are interrelated to each other. uh, am I making is it sounding clear to you guys? Like, can you just reply me in a chat, yes or no, if it is clear? Okay. So this is what a relational database is. You can use different, like you can find a relationship between different tables, and that's why we call it by the name relational databases. So the relationship between tables and the field types in a relational database is known as a schema. Okay. So we have seen in the three tables that we have that each of the three tables are providing a unique information about a specific dog. Okay. So, so this is what a relational database is. You can derive a relationship between these three tables using, using a tabular schema. A tabular schema is tables and is the features and the tables in that are comprised together. Okay. Also, the relational databases are known as SQL database, where SQL stands for Standard Query Language, and it is the language relational databases are written in. Okay. SQL is also used to execute queries and retrieve data and edit data by updating or deleting or altering the new record or creating a new record. So we can use SQL or any query language to change the table, to manipulate the table, and to extract features data from that table. There are these there are quite popular relational databases that we have that we are currently using, such as the Microsoft SQL Server. We have MySQL and we have PostgreSQL. And the entire class that the entire coding part on SQL that you all will be doing is in PostgreSQL, and will be using PostgreSQL along with pgadmin in order to do the practical in the class. Okay, so I have a question from the chat. Is SQL is standard query language or structured query language? So SQL is structured query language because we have defined the query that we use to fetch data from a relational database is in structured format. We have few keywords that we have to place in an order so that we can fetch data. So it is structured query language, not standard query language. Okay. So I guess I have one more question in the chat. Okay, so yeah, so no more questions. Okay, so the popular relational database that we are using are Microsoft SQL Server, MySQL, and PostgreSQL. And then we'll be using PostgreSQL as our coding platform for this lecture and the next lecture on SQL as well. Now moving to what is a non-relational database. Okay, so everybody is clear with relational database. Can I just have a yes or no in the chat? Is everybody clear on what a relational databases are? Okay. Okay. So let's move back to the type of data that I had given you earlier. So this time, suppose that you want to choose the Word document to store your data. Okay. Uh, and like, what can be the reason to store data in a Word document? Excel sheets are restricted in nature. Like you can only store your data in a row and column format. But Word documents, it's all an open space. The data can come in all different shapes, different sizes, and it needs room to like spread out. So Excel sheets are quite restricted, as well as the Word document or any type of non-relational database is quite open and spread out. So a non-relational database is any database that does not use a tabular schema of rows and columns like that we found in a relational database. Rather, its storage model is quite optimized for the type of data it is storing. And for this reason, non-relational databases are also known as no SQL database, in which no SQL stands for not only SQL. No stands for not only. Okay. Whereas relational database only use SQL, that is structured query language. So let's move on to what are the type of non-relational databases that we usually encounter. So there are total number of four. There are four different categories of non-relational databases. They are document-oriented. They are key value stores. They are wide column stores, and there are graph stores. So a document-oriented database, also known as document store, is designed for storing and retrieving document-oriented information. These can be PDFs, this can be Word documents, text in those documents. The key value stores is form of a dictionary where each key is associated with only one type of value. And this is one of the simplest databases among all the NoSQL databases that are present. Wide column databases are used, although they are using tables, rows and columns like relational databases, but unlike relational databases, the name and format of these columns can vary from row to row in the same table. For example, the number of rows in a particular column can change from one column to another in a non-relational database, whereas in relational databases, these values remain constant. So number of rows in each column will be fixed. Either they can be substituted with the nan values or things like that, but the number of columns in each number of rows in each column will be fixed. And the fourth one is the graph stores, where we have nodes, edges, and different properties of a graph to store the data. So an example of graph database could be your Facebook, the information present on your Facebook, LinkedIn, Instagram, where you have a bunch of friends, and the mutual friends to all those friends are projected in a graphical space. So you are the node, and the relationship between you and your friend is known as an edge. So this type of databases can be used to store uh, so non-relational databases can be used to store this type of information. uh, So any question from the non-relational database part? And is everybody clear with this part so that we can move forward? Great. So let's move forward to see that what kind of database should we choose when we are given a particular type of data. Okay. So there are four questions or four questions that one generally asks when before deciding what to choose, like before choosing a database. The first question is, what type of data will you be analyzing? Uh, so I want people in the chat to reply that suppose that how will my choice of database depend on what type of data am I analyzing? So please let me know in the chat, what do you think? How will my data source of data or the format of data uh, be determine what type of database am I using? Okay. Yeah. So like people are telling that like I have got many answers that tell that either it is a structured or is it an unstructured type of data. Yeah. So if we have if my data fits comfortably in rows and columns, it is better suited for a relational database. And if my data is a bit flexible, such as images or text, then we need a non-relational database for that. Now, the second question is, how much data are we dealing with? Right. So suppose that I have say millions and billions of rows, that and say millions and million of column as well. So what type of database should I go with? So it is a good rule of thumb that the bigger the data set is, more likely we use a non-relational database to store it, because non-relational database can store unlimited sets of data with any type and have flexibility to change the data type. Whereas in relational databases, we have to do multiple and intensive read and write operations. Suppose that we are storing a big data in an Excel sheet, we have to do multiple read and write operations, which either increases the traffic between the database and our application and slows the entire process. And this gives like it takes too much time to do these intensive read and write operations or manipulate the data set. So it's a rule of thumb that if you have a very large data set, you go for non-relational database, and if you have a small to medium sized database, then you will have to go with uh, relational databases. The third question is, what kind of resources can you devote to set up and maintain your database? So the question is structured such that you are by resources I mean the type of people that you have working in your team. Like suppose you are a bunch of data scientists. Say okay, see we have 41 people today in the call. So let's say that we are 41 data scientists and we want to store a data set. We want to store a particular data. Now suppose these 41 data scientists come from different backgrounds. Suppose someone is engineer, someone is a statistician, and someone is say of a non-engineering background, and things like that. So everybody is of a different background, right? So what do you think? Is it easy for everybody to learn a non-SQL database, non-relational database, or is it fairly easy for everybody to learn SQL database? Yeah. So it is fairly easy for people to learn a relational data query language rather than go for non-relational databases such as MongoDB or Redis. So that's why if we have a small engineering team of say 41 data scientists, it is better that we use a relational database, because one, relational databases take less time to manage, and SQL is also a very well known query language, right? So it is more likely that the team will learn it very quickly. On the other hand, non-relational databases require more programming knowledge meaning the team has to learn different types of languages. They need to learn Python, they need to learn DBMS, they need to learn MongoDB and things like that. So will need to hire people who already know those skills, and it is not easy for small teams to work on non-relational databases. And the last thing is that, do we need real-time data? So like there is a serious buzz around analytics that around real-time analytics, like the competitive edge that it brings, and like things we extract real time from any website or things like that. Okay, so it is important that every organization needs real-time data. So this real-time data, uh, what do you think? Where can this real-time data be stored? Okay, like we will store these real-time data in a database, but what type of database? So now suppose that by website, suppose I mean the price of airlines or price of flight tickets. So price of flight tickets or price of airlines is a very volatile or very changing parameter, right? So if these changes are quite like if the thing that we want to analyze in real time is very fluctuating and is very volatile, mm, we need to shift to a non-relational database. Whereas if we want to analyze the past records, and we have to see if we see that these prices are not very volatile, such as what can I say, what is which prices, like the price of groceries or price of manufactured goods, these prices are not very volatile, and we can use past records to predict them. So for that case we use a relational database. Okay. I hope I'm clear with what type of database should be used, and like uh, depending on the problem statement, right? So if everybody is clear, we can move forward with our introduction to SQL. Great. So let's start by with a basic introduction to what SQL is and what are the several parts that an SQL language has. So SQL, or structured query language, is a computer language aimed to store, manipulate, retrieve data stored in relational databases. Okay. SQL language has several parts. They are DDL, that is the data definition language; DML, that is data manipulation language; view definition; and transaction control. So let's have a look at the first two, DDL and DML, in a bit detail, because these two are the most important parts of an SQL query. Yeah. So data definition language are used to define the database structure or the schema. Yeah. So DDL statements can be to create a table, to alter, to drop the table, to drop a particular column from a table, or to rename a particular column. Like they are used to define things in a SQL schema, or a database schema. Whereas data manipulation languages, or yeah, so yeah. Whereas the basic or data basic whereas basic data manipulation languages are used to manage data within the schema of objects. They cannot be used to create something, but they can be used to alter things inside already created tables. They can be used to select a particular column. We can insert a particular data in a particular row or particular column. We can update or delete specific rows based on our requirements. So this is a data manipulation language, the part of SQL where we manipulate the data, and DDL is a part of SQL where we define the data. We have defined the database structure. Now let's move on to what is the basic structure of an SQL query. So the general structure is, we have to select the general queries or general keywords that we have in an SQL query are select, distinct, from, in, between, like, I like, and like we'll be discussing these things in detail when we move forward with our coding assignments. So let's stop the PPT for now, and let's move on to understand to getting to know how do we install the PostgreSQL and pgadmin on our laptops, so that we can continue further with the class. Okay. So let's begin with understanding what PostgreSQL is, right? Just give me a second. Yeah. Yeah. So PostgreSQL is like a database or a relational database language that is used to store and retrieve information through SQL queries. So when you need to install PostgreSQL in order to load your databases and in order to use query data from a database. So what you do is you go to this website postgresql.org and you go to the download section. Now you need to select the operating system that you have. So for now, if I'm using a MacBook, so I will go for Mac OS and I'll see which is the latest PostgreSQL version available for me right now. Okay. Okay, so we have a question here. Is MySQL different from this? So Sirish, yes, MySQL and PostgreSQL are just different database tools to store data. The query language or the SQL language that you write to fetch data from different databases are not different on a on not very different. There can be few syntax changes like putting of a semicolon or capitalize the SQL keywords, but the basic syntax remains the same. So MySQL and PostgreSQL are different, are quite different because they are different databases to store your data. So if you have MySQL in your system, that's not an issue. You can use MySQL to to use do the queries that we will be discussing today. What you need to do is you need to get the database that we are using right now. You can see it in the course materials that the database has been uploaded. You just download that database and you can use MySQL to just write the queries. Uh, so Sirish, is it clear? Just can you let me know if it is clear or not? Okay, cool. So I guess you can go ahead. Yeah. So what do you need to do is you need to select your operating system and you need to see which is the latest version of PostgreSQL available for your operating system. So for example, for me it is 13 available right now. So you click on download the installer button and download the latest version of PostgreSQL on your system. Once you download I'm not downloading it now because I have already installed it in my laptop. And so once you download it, you have to run your installer, and you need to take 2 points into consideration. Actually 3 points into consideration. The first point is you need to set up a password in order to use your PostgreSQL. Okay. So try to think of an easy password that you like, you can remember one. So because if you forget that password, you have to repeat the installation process again. Like you have to uninstall the entire application, you have to reinstall it again and then set up a new password. This was point number one. Second point is you need to set up a port number for installing PostgreSQL. Now by default, I guess 5433 or 5432. This will be the ports available when and will be default value of the ports when you try to install the PostgreSQL. But if it is a different value, don't panic because like that your laptop is having that port already. And the third thing is that you have to make sure that your firewall is not blocking that port. Like Postgres can use that port, is not being blocked by any firewall. So after you install Postgres SQL, you have to download another thing called pgadmin. So pgadmin is a UI or user interface for accessing Postgres tools. So you head on to pgadmin.org and you go to the download section. Again, just select your operating system and download the latest version of PostgreSQL pgadmin. Now again, while installing pgadmin also, you need to set up a password. So try to keep password of PostgreSQL and pgadmin the same because it will help you remembering it. And every time you log in into pgadmin through your system, you need to enter that password so that you can so that you can keep using pgadmin. So if you forget that password, you have to uninstall Postgres and pgadmin again, and then you have to reinstall them again. So these are the 3 points that you should consider. First one is keep a safe password. Second is check the port number, and the like it will be 5433 or 5422 by default. And the third one is to make sure that the port is not being blocked by a firewall. So if you keep these things in mind, then you will not have any problem in installing and using pgadmin and PostgreSQL. Okay. No, Priyanshi, you don't have to download it right now because you'll be having the lecture recording with you and the code that we are using with you after the class. So what you can do is after the class is over, you can download pgadmin and Postgres, and then you can start doing your assignments on that, or you can revise what you have been taught in the class on that. Okay. So let's move on to pgadmin and understand what pgadmin is. Okay. Now, when you log into pgadmin, you will be shown uh, data. You will be shown this page. Ignore this for right now. Ignore this thing for right now. You will be shown this page. Okay. Yeah, you'll be shown this page. Now you have to load your data into it, and the data that will be loading will be available to you in your course materials. It is known as DVD rental. Now it is a DVD rental is a .tar format and .tar DVD rental .tar, and you should not try to open it like without this PostgreSQL or pgadmin, because it might throw some errors. So don't try to open it by double clicking on it. Just load this into your pgadmin and then carry on doing the query and the data manipulation. Okay. So where were we? Yeah. So you have to just load your database and don't try to open this dvd rental.tar on your by double clicking it. Just open it using your pgadmin. So now let's try to okay yeah after you load the DVD rental database, we will try to explore the database and see what are the different tables and different data types that are present in this. So for that, go to schemas and go to tables. Now you can see this DVD rental database is actually a database that is consisting of different movies that a particular shop is giving for on rental for rental purposes. Like you go to the shop, you ask for a movie, and you pay the rental amount, and you can rent the movie. Okay. So there are total about 15 tables in this entire dataset. That is the actor, which has the which has columns like actor ID, first name, and last update. You are having the address, which has columns like address ID, address 1, address 2, district, city, things like that. You are having films, which has columns like film ID, title, description, language, release year, rental rate, like what is the rental uh, price that you have to give to rent the movie, rental duration, like for what amount of time can you rent the movie, and things like that. So there are total number of 15 columns, and like you are free to explore each of the columns on your own and different tables on your own. So but for purpose of this lecture, we will be using 4 to 5 different tables, and we will be writing our codes on that. So let's move on to this basic SQL queries and understand each of these queries in detail. So if you are having any doubts until now, please let me know in the chat. Or if we are clear, if everybody is clear, we can move forward. Just ping a yes or no in the chat. Yes for we can move ahead, and no if you have any doubts. Okay, so I have a question, that is Postgres case sensitive? So I'll be answering this question in the course of the class. Please hold on to the question for 2 minutes. We will be using this. We'll be answering the question when we continue forward. Okay, so I guess everybody is clear until now. So let's start with the basic select and distinct statements. Now, suppose you have a table. Suppose that you have this table only, and you want to extract, say, name of the dog from table number one. Say this is table number one, and you have to extract name of the dog. So what we do is we use the select query, select statement keyword, and select the name of the column from the name of the table. So the basic syntax for a select query is select name of the column, select name of the column from name of the table. Select is the most common statement used, and it allows us to retrieve information from a table. Okay. So let's see in Postgres, what does this mean? Suppose that I want to say I want to choose the table actor. Okay. And I have actor ID, first name, last name, and last update. Now I want to say select the first names of all actors from the actor table. So what I do is I select this query and I just run it. So as you can see, I have the first names of different actors that are present in our entire data set. Now suppose I want to select two columns, say first name and last name. So what I do is I select this query and I just run it. So as you can see, I have first names and last names here. And as you can see, if I have written first name before last name, so I have my result in the form of the first column that I have written here and the second column that I have written here. Now, if I want to interchange the columns, I want my last name to appear first. I just have to select last name before first name. So when I run this query, you will see that I have my last name as the first column and first name as the second column. Now coming to the case sensitive question that somebody asked in the chat. So suppose that I use a small like I use lowercase to write my SQL keywords. So even if I run this right now, my query will run successfully because SQL Postgres is not case sensitive. So, but it is a good practice to write the SQL keywords in capital, in capital like bold alphabets, because it gives a good readability and it is better. It is makes people easy to understand like what you are writing. Also, what you can do is you can use a semicolon after every SQL statement, and it this is also good for readability. But for like I don't practice using it too much. But if you are using it, it is a good habit. Now, suppose that we want to select, like in order to select the entire table, we use select asterisks, and we can select the entire table. And sometimes, uh, so let's go and select an entire table from entire all the columns of a table called actor. So when I write select star from table and I run this, I'll have all the different columns that are present in that table. Now, what I can do is I can also write this star in parenthesis, which means that because okay, sorry, not this one. So when we select a star from select star from actor, we select all the different tables, different columns that are present in that table. Now when we use a parenthesis, we are deciding the number of columns, the all the columns on which we are running a particular SQL operation. So when we use a parenthesis right here, we are not running any operation on on these columns, so it will give me an error. We'll see in the coming code that when do we use a parenthesis, and what happens when we use a parenthesis with different SQL keywords. Now moving on to the next SQL keyword, that is a distinct keyword. So sometimes a column might contain duplicate values, and in order to return only the unique values, we use a distinct statement in combination with a select statement. So suppose that I want to select all the columns from a particular table called film. Okay. So when I run this query, I'll have all my different uh, columns, so film ID, title, description, release year, and things like that. Now suppose I can see that 2006 is a repeated year, and I guess there are ten thousands of rows in this column. So I'm not able to see what are the distinct release years, or what are the distinct years in which the movies were released in our database. So for that, what I can do is you call a distinct keyword on my column release year. So when I run this query, I will get only the distinct values of release year, and it will eliminate all the duplicate values. So when I run this, okay, so I see that only 2006 is present, which means that all the movies that we have in our current database were released in 2006 only. Now coming to the parenthesis part, we can see that so we are applying a distinct keyword on our column release year. So that's why we are putting release year in a parenthesis, right? both the statements will work in fine individually, but it the second part gives a good readability because we are clear that on which column we are applying the distinct keyword, right? Now suppose that I want to select distinct rental rates from the table. So we can see that there are three different types of rental rate. There are 2.99, 3.99, and 0.99. So these three are rental rates on which movies are being rented to the customers. So is this distinct and select statements clear to everybody? Please don't reply to me directly. You can just message in the chat, like reply to everyone. Okay. Okay. So the parenthesis part is not clear. Okay. So I'll try to explain it once more. Suppose that uh, so we use parentheses for a better readability and better readability because when we are applying a particular SQL query on a particular column, we want to make sure that it is easy for people to read on which columns we are applying this. So in this case, we are not like this is a fairly small SQL query, to be honest, and it is very easy to read because of the length of the query. But many times as a data scientist, you need to write queries that are say 5 to 6 lines, big. So in that case, it is very like it is important to use parentheses so that when you read the query second time, like after some time, you get to know instantly that on which column have you applied a particular function. Okay. Uh, So I hope I'm clear, right? Yes, Rajat, distinct mean unique values in a particular column. Now let's move on to the count statement. So count returns the number of input rows that match a specific condition of query. So count can be applied on a specific column or just passed as count star, giving the same results. So do you guys like? I just told you a few minutes back that the asterisk can be used to return all the different columns in a particular table. So since it is a relational database, the number of rows in every column will remain same, right? So either you apply count on a particular column or you apply count using asterisks, you are bound to get the same results. Am I clear on this part? Just let me know in the chat. So what I meant is if I apply, since it is a relational database, the number of rows in every column will be the same. So either you apply count on a particular column or you apply count using asterisks on all the columns. The result will remain same because count returns the number of rows that matches a particular query, right? So let's see it in action. So okay, so let's see it in action and like see what count statement does. So the basic syntax of for count statement is select count column name from table name. Okay, and see this time also we are using parentheses. Suppose that we are selecting suppose the payments table, and we see that just a second. Okay, so I have a question here that will this be same for non-relational databases as well? So as I while discussing non-relational databases, I pointed it out that there is a particular type of databases that is known as wide column stores. Like I hope you guys remember it. See the wide column stores. So this is also a database this database also uses tables and rows, but unlike relational databases, the names and format of the columns can vary. This means that the number of rows in the columns will not be fixed. So in this case, we cannot use asterisks like it is a no SQL language, so we cannot use SQL first of all to query a non-relational database. We have to use something different, which is not in today's lecture. So I will not be studying about non-relational basis today. We'll just focus on SQL part. So let's see the count function in action. So suppose that we will select every column from the payments table. Yeah. So we have payment ID, customer ID, staff ID, rental ID, amount, and payment dates. Now I want to find out how many rows are there in this table. So what I can do, either I can scroll down to the bottom and see like there are around like, okay, so this is a fairly big database, so I cannot scroll down to the bottom and see it. So what I do is I just try to I just count the number of rows present in this using the count statement. So I have total of 14,596 different rows. Okay, now suppose that I select the amount column from the payments table. Now I can see that there are different types of amount: 799, 1.99, 2.99, 5.99, and more or less we find repeated values in this also. So I want to see the distinct amount, like what are the total number of distinct values that one has to pay in order to for the movie. So I will use the query of select distinct on the amount column from the payment table. So when I use this, I can see that there are a total number of 19 rows. But suppose that this 19 is also say in thousands, and we have thousands of distinct uh, amounts that are paid. So we can use count on this distinct amount from the payments table. Now there is a difference in this statement and this statement. In this we are using a parenthesis on distinct amount, and here we are not using any parenthesis. So here the basic difference and basic importance of parenthesis comes in. Suppose I try to run this statement. Okay, it will give me an error because we don't know on which column is count being applied to, because distinct is not a column. Column name is amount. So let's run this statement again. Yeah. So in this statement, we can see that we have a column name and amount. So distinct is not a column. Amount is the column. But when we use distinct column together, distinct amount together, it becomes a column of distinct unique value of all the amounts. So when I apply count on a column known as distinct amount, then I will get a correct result. See 19. So I hope you guys understood that why we are using parentheses in this case. Is it clear to everybody? Great. Okay. So let's move forward to the next SQL query that we have. So next is the where statement. So where statement allows us to specify the conditions on columns for the rows to be returned. So just an example that I want to take here. Suppose that I have selected the payment amount from here. Okay. Now I want only those rows which have amount value of 7.99. Or I want only those rows that have amounts between 1.99 and 5.99. So in this case, I will use the where statement. So where statement allows us to specify the conditions on columns for the rows to be returned. Now there can be two different types of operators. One is the mathematical operators and another one is the logical operators. So in mathematical operators, we have equal to, greater than, greater than equal to, less than equal to, or not equal to. So this means that where x not equals to, or where x is less than, or where x equals to. And the second one is logical operators. So this can be used to combine two different mathematical or arithmetical operators, or not in every case. For example, if you want to say that x equals to y and x less than z, or x equals to y or x equals to z, and things like that. So this is the where statement. And now let's see where statement in action. Yeah. So the basic syntax of where statement is we have to select column, says I am selecting column 1 and column 2 from table name, and we have to specify the where condition. Now suppose I want to select the customer column. Okay. So I selected all the columns from the customer table. So I have customer ID here, store ID, first name, last name, things like last update, create date, activity bool, address ID, and things like that. Okay. Now I want to select all those rows where first name is equals to Jared. So suppose that I run this query, select all those columns where first name is equals to Jared. So when I run this, I get a column where the first name is equals to Jared and all the details regarding this thing. Now, What I can also do is select, say, store ID. Like instead of asterisks, I can write the different column names that I want. But like let it be for this purpose. So if you want to say see only customer ID and store ID, just write here customer ID and store ID, things like that. We select only those columns that you want to that you want to see in the results. Now, okay, can anybody tell, is it a good practice, to use asterisks every time, or is it a bad practice to use asterisks every time? Like, think upon this and just let me know. Is it a good practice or is it a bad practice to use asterisks every time? Uh, I cannot see the Q&A from the webinar attendees in the webinar. Yeah. So, okay. So I have a 50-50 answer on this. Like if a few people have told that it is a good practice and few are telling it is not a good practice. So actually it is not a very good practice to use asterisks every time, because the more number of columns that you query on, it increases the traffic between your application and your database. So don't use asterisks every time to check information. Use only those columns on which you want the information, but since this is a toy database and we have only 14,000 rows, so it is okay to use asterisks because it won't take too much time. But in real time applications, when you have data in millions and billions, don't use asterisks every time. Only select those columns on which are really important to your use case. Yeah. So where were we? Yeah. So let's select all the, we use this query where we have selected all the columns where the first name is Jared. Now let's see the film column. Select all the columns on the film table. So we have film ID, title, description, release year, rental duration, and rating for rating. And rating, I guess rating is a categorical variable. We have NC, R, PG-13, PGG, and things like that. So suppose that I want to select a movie whose rental rate is greater than 4, and the replacement cost is, where is the replacement cost? Yeah, it's greater than or equal to 19.99. So when I run this query, I'll have those movies which satisfy this criteria. So you can see the rental rate is greater than 4 every time, and replacement cost is also greater than or equal to 19.99. Now I want only those movies whose rating is also R. So when I run this entire query, I'll see that the rating is also R in this case. Okay. Now, suppose that I want to count the number of films that satisfy this criteria. So what I can do is I can just use a count query on this column, on my all the columns, and it will give me the number of movies that satisfy this criteria of mine. So there are 34 movies which satisfy these three criteria. Okay. Now, let's say we select a movie with rating R or a rating of PG-13. So it's fairly simple in this case also. We selected movies with rating R or with rating PG-13. And third case will be where the rating is not equal to R. Like it can be a movie with any rating other than rating equal to R. So you can see that we have all the movies with rating other than rating equal to R. So is this where statement clear to everybody? Great. I guess we can move forward. So let's move to another statement called order by. Now, okay, one more thing that I want to say, that whenever you will try to run these queries on your computer, you might witness that uh, there is a different order in which the data is displayed. For example, for you, Bright Encounters might be the first movie to be displayed, and Chamber Italian can be go at 3 or 4. But like this data can be in any order. This depends on the your configuration of the system and the version of PG admin that you are using. It is not a big issue to be like it is not an issue to be dealt with in the first place. Okay, so we have a question here. The question says that do we need to make a query every time we need some data to do analysis? Can we not use data from already made queries? So Smriti, actually, no, you don't need to use data. You don't need to make a query every time you need some data. What you can do is you can store this data into particular tables and like see, we are trying to learn SQL right now. So for this purpose, I'm using a query every time. But if you want to use it in a real-time application, you need a entire pipeline where you fetch data through SQL, you convert that into a Python database using pandas or something like that, and then you do operations on that using Python. So for that, you need to convert this data into a usable format, right? So in that case, you have to do analysis on already made queries. So for just for this case, I am showing you every time, like querying every time, but it is not necessary actually. So Smriti, is your doubt clear? Great. Yeah. So where were we? Okay. So we were discussing that like although okay, another we have another question. Okay, so is it it's only for fetching data? So yes, so SQL is right now whatever we are learning is to fetch data. We can also in the next lecture actually we will also learn how to alter the tables in the given database, and we create new tables and things like that. We will be using manipulating techniques to manipulate the data like after fetching the data, we'll manipulate the data also through SQL only. But right now in this lecture, we are only concentrating on how to fetch the data and what are the different techniques to fetch the desired data that we want. So Sirish, is your doubt clear? Great. Yeah. So okay. So what I was telling is that when you will run these queries on your systems, then it is not necessary that you will find the data displayed in the same order. You can find the like bright encounters in the first place, and this chamber Italian can go at the last. This entirely depends on the version of PG admin, the version of PostgreSQL you're using, your system configuration, and things like that. But like don't worry because like it's completely normal. Okay. So moving forward, the order by statement. So as I told you, the order can change. Order in which the results for you will uh, be displayed can be different from what it is in mind. So you will be learning about the order by statement in order to like clear this. So order by statement is used to sort the entire table with respect to a particular column or with respect to multiple columns. For example, suppose that I have a company or like I have a table in which I have a company column, name of the sales employee column, and the number of sales that an employee has made column. Okay. Now I want to sort this entire thing by company. So don't look here at these two table right now. Just I want to sort the entire table by the company format. So when I try to order by sort this in ascending order in lexicographical order, alphabetical order, then I will have Apple at first, then I'll have Google, and then I'll have Xerox. Now, after I sort the company in ascending order or alphabetical order, I want to sort the sales made by different persons in ascending order after we have sorted the company. So we have sales in Apple of in 100 and 300 sorted. We have sales in Google at 200 and 500 sorted in ascending order. And then we have sales in Xerox. So we have sorted two columns. We have sorted the company column first and we have sorted the sales column second. And for that, we use a syntax, select company name or select the column name from table name and order by the different columns that we want to sort the table with respect to which we want to sort the table. Now, what we can do, either we can sort it in ascending order, either we can write an ASC if we want to sort it in ascending order, or we can write a DESC if we want to sort it in descending order. By default, order by uses ASC format. Like if you don't specify anything, it will take ascending order to be the default value. So now let's move on to PG admin and deep dive into some of the like hands-on thing. Okay. So suppose that I'm selecting the customer column, and in customer column, see I have customer ID, store ID, first name, last name, and things like that. Now I want to sort the entire table using in ascending order or in alphabetical order using first name. So for that, I'll use order by statement. And when I use this, you'll see that the first names are sorted in alphabetical order. I have Aaron, Adam, Adrian, Agnes, Alan, and like in alphabetical order, as you can assume, right? Now, suppose that I want to order by store ID, because I can see that there are store one, store two, and things like that. So if I try to order by store ID, uh, as you can see, I've selected only three columns: store ID, first name, and last name. So okay, so I can see that store number one is constant here, and then I guess we will have yeah, we have store number two also. Yeah, so we have store one, store two, and I guess many more stores. So let's see that. We want to sort it. Suppose that I want to sort the different store. I want to sort the entire table first by store ID, and then I want to sort it by store name. So when I use this query, so as you can see, we have first sorted the entire table by store ID. So for store one, then I have sorted the entire thing by first name. Okay. So we have store ID one, then we have names sorted in alphabetical order: Adam, Alan, Albert, Alice, and things like that. Now, if I go down, I guess when I have store two, yeah. So here I see I have store two also. So I have Aaron. Like after store one has been completed, we have store two, and the names are sorted again in alphabetical order, starting from store two. Now, suppose that I want to sort the store ID in descending order and the first name in ascending order. So I can just specify after the column name, right? So suppose I am trying to sort the store ID in descending order and the first name in ascending order. So when I use this, I have like the reverse of the table that we have seen right now. Second store we have Aaron first name and things like that. So this is the order by statement. So guys, is this clear to you? Like why do we use order by and how do we use to sort different tables? Okay, so I guess everybody's clear. So I guess we can move into the uh, next part. So just give me 2 minutes. Yeah. So let's move on to the next SQL query, SQL statement, that is the limit statement. Now, whenever like suppose that whenever we are using whenever we are using this statement, select star from customer, we are seeing multiple different rows. Like the entire table is being displayed. But suppose that we want to see only the first row or see only the first two rows. For that case, we use the limit statement. So limit statement is a command that allows us to limit the number of rows returned for a query. It is useful for not wanting to return every single row in a table, but only the top few to get an idea of table layout. So so suppose that you have been using pandas, right? So you have been using you want whenever you want to see the top five or top 10 rows of all and all the columns in a particular data frame, you use df.head, right? Or you either pass a variable into df.head, so the number of rows that returned for that number of to allow the number of rows to be returned, right? Because df.head takes only five as a like I guess five as the basic default value. So same is the case is limit. If you want to see the limit the number of rows for a query, you will use the limit statement. So limit also becomes useful in combination with order by and various other things that like in any use case, you can have multiple use cases of limit, and limit goes at the very end of the query request and is the last command to be executed. So when you use limit at the end of the query, what does this mean? It means that you have returned the entire table as but you want to display only the limited number of rows. So that's why limit goes at the end of the query. So now let's see a few use cases. So suppose I want to select only the first row from the payment table with all the columns. So I can use limit one. Suppose I want to select on top 5 rows and from the payment table where amount is not equal to 0, like for which amount has been paid, right? And I want to order it by the payment date in descending order. So you can see that the date is the format of year, month, and day. So we can use order by on the payment on date time as well. So when I run this query, I want to select all the columns on the payment table where the amount has been paid, like the amount is not equal to 0, and I want to order it in descending order by payment date, and I want to display only the top 5, like I want to find only uh, like the recent payments that have been made, right? So I will sort it. I will get a top 5 recently made payments. I guess I have a question. Okay, so the question is, could we write all the queries in one line? Just you can write all the queries in one line, but like it won't be a very good. It is not a good practice as such. So try to like keep things in different lines, like SQL keywords in different lines, because it is quite readable when you look at it after some time. So, okay, do you guys get this? Because so I want to see the top 5 latest payments that I have received, uh, in the payments table. So for that, I'll sort the payment date in descending order, and I'll see the only the top 5 results. These are top 5 latest made payments, and this is the use of the limit function. Like we can use limit in multiple ways, but this is one of the uses. So is everybody clear with the limit statement? Just give me a yes or no in the chat. Great. So let's move on to the next SQL query, that is the between statement. So between statement can be used to match a value against a range of values. So remember we have studied the where operator just a few slides before. Between operator is also sort of similar thing, like not exactly the same, but it can be used in a similar fashion. Suppose I want to find a value between x and y. So a value between x and y includes x and y also. Suppose that I have a list of integers, say 1 to 10. I want all the values between 4 and 8. So I'll have values 4, 5, 6, 7, 8, which is similar to writing, give me all the values where the lower value is greater than equal to 4 and the higher value is greater than equal to 8. So I'll get all those numbers that lie between 4 and 8, including 4 and 8. Uh, are you guys understanding? Please, please let me know in the chat if this statement what I have made right now is clear to you. If I'm going fast, please let me know, guys. Am I going fast? Should I like decrease the pace? Uh, like, is I have not. Is this yes for? Am I going fast or am I like? Okay, it's a bit fast. So okay, I'll slow down a bit. So okay, okay, no more replies right now. It's getting a bit confusing. Uh, yeah, I'll go a bit slow right now. So the between statement can be used to match a value against a range of values. Suppose I have a list of integers from 1 to 10, like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I want to find all the values that lie between 4 and 8. So 4 and 8 will also be included in my result. So my result will be 4, 5, 6, 7, 8, which is quite similar, exactly similar to writing, give me all the values where the lower value is greater than or equal to 4 and the higher value is less than or equal to 8, which will also give me the result of 4, 5, 6, 7, 8. So between statement and where statement are a bit of similar things, but they work in a different fashion. Is this clear now? Please give me a yes or no in the chat. Is this clear? If it is clear, great. Uh, so this between operator can also be used to with the not operator, which means that something which is not between 4 and 8. So what will be the answer in this case? We have a list of integers starting from 1 to 10, 1 to 3, 4, 5, 6, 7, 8, 9, 10. Now I want all those integers which are not between 4 and 8. So in this case, 4 and 8 will not be inclusive in this statement. So I'll have the result as 1, 2, 3 and 9, 10, because all the 4 and 8 are included in not included in the not between operator. Are you am I clear? If I use not between in this case, then the 4 and 8 will not be inclusive in this statement. I'll have only those numbers that are less than 4 and all those numbers which are greater than 8. Okay, I guess it is clear. Also, the between format can be used with dates, but there is a bit of catch here, which I'll tell you when we go to the coding part. So I hope the between statement is clear. Let's move on to the coding part. Let's jump in. So suppose that I have selected a payments table and I have amount of 7.99, 1.99, 2.99, very distinct amounts that we discussed earlier, 19 total amounts. Now I want to see all those amounts that are between 8 and 9. So I guess we have only one such value, that is 7.99. Okay, sorry, 8.99. Yeah. So 8.99 lies between 8 and 9. Now suppose if I change here to 7.99, then I think we'll have values. What I don't think, like I know that we'll have values that include 7.99 also. But if we write not between 7.99, we will see that 7.99 is not included in this because we have all the values that are less than 7.99. Am I making sense? Is it getting clear? Is it getting clear? Please reply yes or no in the chat. It is a bit tricky part, I guess, but like tell me if it is not clear. Great. Now coming to the date part, we can also use between statement between date formats, and the date format is fixed in month, sorry, year, month, and day. Y, DD. Similarly, DD. Now, suppose I want to see that what are the payments made, that what are different payments made between 1st February and 15th February. Okay. So when I try to run this statement, I see that all the payments have been made on 14th February, like on 14th February, 23 hours, 23 hours, 21 hours, 22 hours, and things like that. So as you can see, there are total 27 values here, and all these payments are made in on 14th February only. So if I run select like bit where payment date is between 1st February and 14th February, should I get the same result? Like it is intuitive that I will get the same result, right? So, but when I run this, I don't have any result. So the reason for this is like for in SQL, the date time starts at 0 hours and not at 24 hours, which means that when I when I take payments between 1st February and 14th February, I'm taking payments all between 1st February 00 hours and 14th February 00 hours. But all my payments on 14th February have been made after 00 hours, like after 12 a.m. So that's why we are not getting any result when we are running this query. So that's why it is very important to like check for the date time parameter whenever we are using that in our query. Have I made myself clear? Just let me know in the chat if the between statement is clear to you guys or not. Great. Okay. So let's move on to the next SQL query, that is the in statement. So the in operator is used to create a condition that checks to see if a value is included in a list of multiple options, or it is not included in the list of multiple options. For example, if a user's name shows in a list of known names, so for that we use like the value we want in the different options that we have. Okay. So I guess a bit of coding like assignment will give you a bit of more info about the in statement. So the basic syntax of in statement is select column one from the table, where column one have values between in value one and value two. Now, suppose that we have the we select the payments table again. We have the payment ID, customer ID, staff ID, things like that. And now suppose that we want to select a distinct amount in the payment table. So like we have these distinct amounts and we want to sort by this amount. Okay. We want to order by an ascending order. So we have 0.99, 1.98 and things like that in ascending order. Now suppose that I want only those rows that have amount in 0.99, 1.99 and 1.98. So you can see that we have this 1.98, 1.99 and 0.99 in our amount column. So we will have only those rows that have amount in these three values, as you can see here. Now suppose that I want to have only those rows in which the first name of the person is either of these three names. So when I run this query, okay, so I have a person named Julie and I have a person named John, but I don't have a person whose first name is Jake. So that's why we have written only two rows. So is this in statement clear to you guys? Great. So okay, on this note, we are ending the lecture in this note.